Hi everyone, welcome back to Algebra 1, and today's topic is going to be about solving complex inequalities. Really quick, please go ahead and like the video and subscribe to the channel if you haven't already, and we'll get into talking about how we're going to figure out the strategy into solving complex inequalities. And I will say that this video is not going to be much about concept, as I already did a video about how to solve inequalities. This is going to be a video with me going over multiple examples so you can see how they are worked through. I will say that overall, there's a strategy that I like to use when I'm trying to solve complex inequalities, and it involves three parts. The first one is simplifying, and simplifying is going to involve several different factors that I'm going to write down really quick. So the first one would be PEMDAS. A lot of times when you see these inequalities, you're going to look to see if PEMDAS is involved, and you can use it to make it simpler than where it started. And for refresher's sake, PEMDAS stands for parentheses, exponents, so I'll write exponents, multiplication and division, and then adding and subtracting. Another example of something that we're going to look for to simplify is combining like terms. Sometimes in more complex inequalities, it will be something that is long and drawn out, and it'll seem overwhelming. So if we can combine any like terms, that's going to help us in getting to the answer and getting to the answer quicker. And then also something that we can use to simplify is using the distributive property, which also involves parentheses most of the time. The second part of the strategy involves isolating the variable. If the variable is not by itself, isolating is the next step to solving. And then the last one, once it's isolated, is solving it. So let's go ahead and get to some examples. So we can visually see how it's done. So this is the first one, and I'll write the second one out to save some time. Okay, so for this one here, on the left, we have 2b plus 5 is greater than 5 squared. So the first thing that we want to do, remember, is to simplify. So these are all the options we have. And here I can use some PEMDAS because I have some exponents. So that's what I'm going to do. And I'm going to write everything that I'm going to leave alone out. And then PEMDAS using that is going to be 25. Now I'm going to isolate the variable because 2b is not by itself. So I have a plus 5. I'm going to subtract 5. And since I did it on one side, I have to do it on the other. That's canceled. Then I have 2b greater than 20. But b is still not isolated. It's being multiplied by 2. So I have to divide it by 2. Then I'm going to divide by 2 on the other side. So now b is isolated. And then I need to solve. And then I have b is greater than 10. All right. So for the second one, For the second one, it involves fractions. So what I like to do is do the fraction work, if I can, on the side somewhere on my paper. Because as we can see, we have several fractions, and they are not as similar looking as I would like. They have different denominators, so I want to find a common denominator. So really quick, I'm going to do some work over here. So I'll draw that. Let's do this over here. So I have 4 over 5, 1/2, and then 3 over 5. I want to find the greatest common denominator, or the least common denominator. And all of these on the left can be made with a denominator of 10. And we have to kind of figure out how we did that. So for 4/5, to get it to 10, we have to multiply the bottom by 2. So we're going to multiply the top by 2. That gives us 8. And then for 1/2, we had to multiply by 5 at the bottom. So by 5 at the top, that gives us 5. And then for the third one, we had to multiply by 2 at the bottom. So times 2 at the top, and that gives us 6. So now I'm going to rewrite this with the fractions that are the common denominator. So that makes it 8. Let me write that over because we're going to need space. 8 over 10x plus 5 over 10 is greater than 6 over 10. Now, I'm definitely going to have to simplify it some more because this looks complicated. So what I'm going to do is I'm going to multiply everything by 10 on both sides. Well, I'm doing it on one side. I'm going to do it on the other because that will get rid of all of my denominators. So that's out, that's out, that's out. And then now I have 8x plus 5 is greater than 6. Now I can subtract this 5 from both sides, and then I have 8x is greater than 1. And then divide by 8 on both sides. I'll just put here that then the answer is going to be x is greater than 1. So as you can see in both of these examples, this one more than this one, they are complex. But again, first we simplify, then we isolate, and then we solve. Okay, I have 2 more examples here. Again, this is going to be a practice-heavy video. So I have p on one side and p on the other side. So I want the variable on one side. So I am going to isolate the variable on one side at least. So I have a positive 3. I'm going to do a negative 3.5p. So whatever I do on the right, I have to do on the left, negative 3.5p. And that gives me 2.5p minus 1 is less than or equal to 4. Now, to isolate the variable, I'm going to add 1 to get rid of 1 on this side. So I do that on that side as well. That's canceled. And then I have 2.5p is less than or equal to 5. And then since it's multiplied by 2.5, I'm going to divide by 2.5 on both sides. So then my answer is p is less than or equal to 2. And then for the last one, to simplify it, we're going to distribute because we have some parentheses involved here. So I have 6 minus 6j is less than 3j. Isolate, I have j on each side. For me, it's easier to move the 6 over. So I'm going to add 6. Since it's a negative 6j, I'm going to add 6j to both sides. That cancels, and then I have 6 is less than 9j. Divide by 9, divide by 9. So then I have j, and I can either write it as 6 over 9. I'm going to simplify it, and I'm going to put 2 over 3. But you could write 6 over 9, and that would still be correct as well. One thing I want to talk about that is, I think, important to note, because those will come up in those tricky questions that I like to highlight for you guys, is a tricky thing to take note of. I'm going to highlight it. Is that when the inequality is simplified and the same variable term appears on both sides, keynote is both, so let me highlight that part, on both sides, the solution is one of 2 things, and I'm going to write that out. So the first one is that the solution is all real numbers, or the second option is there's going to be no solution. Let me change this really quick and put or. So in order to know which one, you're going to look at the other terms in the inequality, because you'll see visually that you are going to have the same variable term appearing on both sides. Now, if the other terms in the equality are true, then it's going to be all real numbers. But if the other terms in the equality are false, the answer is going to be no solution. So if it's true, let me highlight that. Wait. The answer is going to be all real numbers, but if it's false, it's going to be no solution. And let me show you visually what I'm talking about. Examples. So we have, let's say, x plus 5 is greater than or equal to x plus 3. You would think you would find out when you try to do it the way we're taught to in class, that if you subtract x here, you subtract x here, you have that gone, you have that gone, then you get rid of your variable. So the point of this part of the video is just to illustrate to you that if you just see it, if you can catch it visually before, you don't even have to work it out, because you now know that if you have the same variable on both sides, example x and x, it's not like it's 2x and then x. No, they're both 1x. So that same variable being there is key. So then at that point, all you have to do is visually look at the other terms in the inequality. So then I'm just going to bring everything down. 5 is greater than and equal to 3. Then you need to ask yourself, is 5 greater than and equal to 3? The answer is yes, it is. So then this means that it's true. Therefore, the solution is all real numbers. Now let's do another example where it's 2x plus 6 is less than 5 plus 2x. Again, we're gonna try to train our eyes to catch that 2x is on both sides. It's not like it's 50x on one side and 2x. It's 2x. So when I try to isolate and bring the other one over, it's going to cancel it out. So just going to take note that they're the same. So then all I have to do is bring everything down and then ask myself if it's true. Is 6 less than 5 ever? No, that's false. So I'm going to put false. Therefore, there's no solution. And that's it for this video, guys. In the link to this video are going to be several practice problem videos where we're going to go into more depth of some relatively easy, but then some complicated ones. So you guys have it a little bit more solidified. So you guys will find it more easy to do your quizzes and your homework. See y'all next time. Take care.